Annoyingly, there seems to be an air leak in our system here, which makes it very hard to get up enough air to use the clutch or the brakes. I think the main air leak is coming from the tank that I fitted that was stuck out in the elements next to the spare wheel just behind the cab. Now that tank, obviously it was out there for a long time, it's probably had some water in it and it's probably rotted a strip along the bottom. I suspect that's what's happening. So we're going to have to take that off and see if we can repair it or replace it. But before we do that, we're going to try and pump up some air into the system without starting the engine. So we're going to pump it up from the compressor and charge it up, give us a chance to pump up the tyres because they're looking a bit soft, and then we'll see where the leaks are and hopefully we'll be able to hear the leaks without the being drowned out by the noise of the engine running. Okay, Mark.
Yes.
We need to find a point where we can pump some air in.
Did we not do this once before?
Yeah.
I can't remember where.
Here. It was just that one there.
Okay.
So that T-piece.
Yeah.
Yeah, disconnected that just below that T-piece and hooked on a rubber tube with a PCL fitting which went to the compressor.
Okay.
This time round I'm thinking possibly we'd just take this one off.
Right.
And use that. Although it is a smaller tube.
Yeah, it's quite restricted, isn't it? Might take a while.
Because what we wanted to do is charge this line.
Yeah.
Because that goes to the valve that feeds the tyres.
Yeah.
This one comes back to the actual wheels.
Yeah.
But we want to get the whole system live.
Okay.
So this one here, this little one, feeds the gauge.
Yeah.
The other thing we could do is to take off the is to pump it into one of the tanks, because the tanks have got drain taps on them.
Have they got sort of cocks we could put rubber on it?
Yeah, maybe. Have a look at the one under the passenger side.
Feels like a normal tap.
Yeah, so we could try to blow air at that.
Yeah.
But there's, strangely enough, there's another one just above that.
Yeah. That one's a bit more seized.
This reminds me, on my Bedford MK,
yeah,
it had exactly that thing.
Okay.
And next to it in a box was a load of rubber hose,
yeah,
and a fitting and a tyre inflator.
Okay.
That's exactly what that was for. You
yeah,
screwed it on there, opened that up, and then you could pump up the tyres.
I think that's what we need to try and find then, is something that we can bodge onto that. That's, I think, the Imperial version of what we need in...
Yeah, so that's 1/4 inch BSP. Right?
Right, okay. So what about this one? Well, yeah, it's got stuff on it.
We'll test it out first, this whole thing might not work.
Yeah.
Right, let's see if it works. So we've got the line from the air compressor tank. That one. Then we've got a short bit of rubber hose as an adapter going onto the tank here. And, yeah. Up. Success then. So we now have the compressor running, charging that tank there, going through this blue lead here into the tank that's under the passenger door and charging up the truck system. So once that's charged, we can then pump up the tyres, which would be a good thing to do, and then we can turn off the compressor and we should be able to hear if there's any leaks in the system. See that red area there?
Yeah.
So the tyre system, the tyre inflation won't work until it's gone past. See the red goes halfway through the 4.
Yeah.
Once you pass there, then the valve will open. So that's to give priority to the brakes, I guess, which is sensible. See it already?
Yeah.
In the tank.
There's quite a major pinhole about halfway along, and
we failed to pump up the tyres then, but we have very much found the source of the main leak. So the pipe's off, so if you poke through that thingy.
do you want me to take that whole thing's off?
Yeah, take the nuts off.
What's the spanner? No.
Just about there.
Just drag it out. Okay.
Yeah. Let's have a quick look then. Got a big hole now.
Yeah, that's not going to hold any air, is it?
No.
Close to that weld there as well.
It's soft.
Yeah. And the fucking hell.
Bloody hell. Yeah, there we go. I think that answers that one then.
Yeah.
So this, when it was installed, this was this way up. You can see that tap there was the bottom. But it seems that it wasn't really draining out of that tap, I guess. But anyway, there's a weak spot all along here. What I'm going to do then is just cut the whole lot out rather than try and patch individual bits. I'm just going to take out a whole section about 2 inches wide all the way down there on the bottom of the tank and weld a fresh bit in. So by using a bit of angle line I can get a fairly square line. Not that it matters too much, but it's going to make it easier to patch it, I guess. So you might think welding on a pressure vessel is a bit daft. Well, there's two things you've got to bear in mind. One, you've got to be confident of your welding, which I am. But two, even more importantly, you need to test it. So once this is welded up, I will test it, and this will normally be running about 100 psi or 7 bar. So I'm going to test it to double that. But I'm not going to test it using air. I'm going to test it using water because it's much safer. Anyway, first step, let's cut this out. Ooh. Yeah, pretty grim. Hopefully the rest is alright. Yes. Smells a bit funny. I've just sanded it just enough to take that burr off so I can get a proper reading. And I'll go in a bit from the edge. What have we got there? Bang on 2. Down the sheet. What I'm going to do then is use this as a template. Obviously it's curved at the moment, so I'm going to flatten it out and then I'll just scribe around this so I don't have to measure anything. Copper hammer then, and gently does it. That's how it looks. So use these magnets and then it shouldn't disappear in the hole. So I should end up with about a 1mm gap all the way round, which is what I'm after. Because I'm going to MIG weld this, and you want a bit of a gap for the MIG wire to get in and actually make a decent bond. What I'll do then is tack the corners. There's some distortion going on here where I put that curve in it this way. It's actually put a slight bow in it this way. But that'll be fine because it's only 2mm steel. I'm not going to worry about that. What I'm going to do is put a hefty tack in each corner here, and then I'll work my way down, sort it all out, get everything lined up before I actually do any proper seam welding. Good, that's one side tacked up. Not cool. So that power setting was too low there. I've always got fluctuating power from because it's coming from a generator, and the generator's not it's not the best. Very inconsistent power, which is not really what you want for welding. That's some ugly welding. It's a bad workman that blames his tools. But that's all the welder's fault. Yeah. Yeah, bloody hell, that's no fun at all.
That'll reach, which it will. That'll probably be the right sort of length actually.
Right, do you want me to fit that plate then?
Yeah, I think if we get that in place so that's fixed then, and that can be fixed forever, I'll probably start with the ignition and go from there.
So this bit of alley plate then is an adapter. That was the plan. So I'm screwing it onto the bulkhead, and then these three here will attach to that electrical box. Alright. Now the box for the magic.
Yeah, but there's probably filming going on, isn't there? The usual sort of thing where I'm just talking all over it, not making any sense. Magic cable of justice. No idea what that was for. Clearly the Russian army had reasons, and I've no reason to argue with them, so I'm going to recrimp this cable, and this is going to be our main 12 volt feed into the dashboard, because the whole point of this was using this box to remove the need for us having a completely separate 12 volt system with its own battery and charger and all that kind of gubbins. I was just going to use this as an interface, run everything 24 volt apart from the dashboard. So this will be our 12 volt supply to the dashboard, if the wire's long enough, and yeah, that should be all we need, and we can keep the Russian supplemental relay right where it is. You're going to be in a position to be able to go into the cab and try and interact with the dashboard in any way.
Well, I tell you what, I don't think I've root all that up to much.
What's that?
I don't think I've root up to much.
Wouldn't someone fixing it?
Well, I guess they're very busy. What do you want me to do?
I want you to just stand by a moment. Okay, so is the dashboard lighting up?
The ignition's on.
And if you turn the ignition off, does the ignition light go off?
Yes.
Cool. So we've got a usable earth, and we've got fat earth actually off of there. So we just start wiring all these in for tomorrow. But I've got what I want to do. Maybe a first thing, because it'd be nice to do it in daylight. We just meter out all those blocks again. What we need to do is start actually disconnecting all of the wiring that comes from the dashboard and goes anywhere else. All of the dashboard wiring has to end up in here, which is going to be fun in games because
Yeah.
I'm hoping that would have worked actually. Off.
Back to 1.
Hang on. Starting position again.
Yeah.
It's interesting. What's going on there then? Ah, probably not a fuse in there or something.
That's looking quite good. Yep. We have a winner. Right, I'll take it up to... Yeah, I'll just put a few PSI in it first, see what happens. Got about 90 PSI in this big air receiver. Obviously 0 in this one at the moment. Let's make sure that tap's closed. Yep. Right, I'm going to open the tap up here. Big leak coming from the hose. Bummer. This is the side where I was struggling to lay a good bead with a welder. There's one there and one there. This side's fine and the ends are fine. So that's about 30 PSI at the moment. So we might as well sort those out first.
Here it is. Today we're going to be mostly investigating the wiring on the ZIL. Electrical. Current state of play is that the ignition, starter circuits and everything are all wired in, so it should be able to start on the key. The bottom row of relays in there are going to be pretty much exclusively controlling the lighting, which I've still got to wire back into there. I'm using the DAF wiring loom pretty much as is because it looked quite neat, and that's it. I think the next stage is to try and investigate whether we can get the 6-wheel drive solenoid working.
Having found some leaks, I decided I wasn't happy with any of this welding, so I've done the entire lot again, and now I've got some massive beads on there because I've had to go over the original bead and hitting both sides of it. But I'm more confident with this welding. It's actually, the generator and the welder are working better together. I seem to have got the settings better.
Yeah, it's very nice. Some of the best welding I've seen. That'll do the job very nicely. Sorry?
You've got to work on your acting skills.
Acting skills? That right?
Yeah.
Okay.
Go on in.
How much should I give it?
Take it up to 2.
You can see it, so it's on that edge. There's one just there.
Yeah. Oh, no, let's have it. Yeah, it's only 30 psi, but no bubbles. I'll pump it up a bit. – 50 psi. Nothing. That's better. We can move on to hydrostatic testing, I guess.
That's when it gets really fun.
No terrifying leaks in the system so far.
It's got a bit of a restrictoroonie on it, but that's probably through the trader valve, isn't it? That's not a bad thing.
No, that's fine.
Sitting there at 2.5 bar and none of this is leaking.
Right, so you're happy to proceed.
Yeah.
Okay, so the next step is we're going to fill that with water
Yeah.
and pressurise it for real.
Should I try and let the air out?
Yeah. Open the tap.
When they're commercial ones, just bare metal.
Yeah.
Presumably why you're supposed to keep blowing the water off of them.
Exactly.
Okay.
Right, so that's tightened up.
Not that it seems to make a lot of difference there, but it'd be interesting to see what it's like under pressure.
Okay, so what we've got now is the tank is full of water. We put the gauge back on. We've done up the tap, and so we've got this tiny bit of hose here with a Schrader valve clamped in tightly. And what we're going to do now is pressurise that using the fire extinguisher, and we're hoping to get, well, at least well above 100, which is 12 o'clock here. If we can get it all the way around to 200, that'd be terrific. If not, well, we'll see. So what we're doing is we're introducing a massive amount of pressure into the system, but because this is full of water, it's a hydrostatic test, and it's not just a massive bomb as it would be if this was empty and we were filling it with air. Under pressure, under the massive amount of pressure that we're putting in, if this ruptures, it's just going to squirt a little bit of water. Nothing dramatic is going to happen. The only drama might come between here and the fire extinguisher, which is the bit we've bodged together. There you go. So by holding the fire extinguisher upside down, it's got a feed tube which goes to about there. Doing it this way, I should mostly get gas out of it instead of dry ice.
Should I move it around a bit more?
No, I think we're good.
Okay.
Right. Now that Schrader valve might fly off into the sky at any moment, so don't get your face near that. Other than that, we'll see what's what. So we're losing pressure, but it's coming out of here. What I'm interested in is if there's any water squirting out of the welds. So the welds are over here.
You got a torch?
Yeah, I've got a massive light.
Cool.
So we're losing a little bit of pressure out of this tap.
That's where this drip's coming from.
Yeah, that's this drip. But the welds themselves all look fine.
What pressure are we at now?
We're just about 80 psi at the moment.
Okay.
So it very quickly loses pressure, and it's losing it from this rubber hose. Probably not much we can do about that.
Will they do up any tighter?
I think they're only Jubilee clips. If they're just going to strip the threads and try and do them up anymore. So we touched it at 200 psi, and there's no leakage coming from any of these bits. What we will do though is dry this bit off, and I'll pressurize it again, and we'll just double check that that bit's okay. Yeah, that's going to be tricky, isn't it? So if I lean it over a bit,
I mean, actually no, because it's leaking out of the tap itself. If you've not got a bit of hose, we could just chuck over that just to stop it dripping there. If it's dripping over there.
Yeah. Alright. So this hose is just to catch any drips that are coming out of the tap, which isn't not a perfect tap.
Because the rest of it is quite perfect.
That's doing the job.
I know, I'm surprised how well that worked.
Right, we're all set?
Yeah.
Okay. I'm going to pressurise it again. Remembering that this is the dangerous bit, is this horrible bodge here and the horrible bodge here. So I'm just going to get my face out of the way of that.
200, well, yeah,
200, that's all we're going to get. So now I'm having a really good look around here, see if there's any leakage.
Down to about 100 psi now.
So we haven't managed to hold it at any huge pressure, but it has touched 200 psi a couple of times. If there was any actual pinholes in the welding, we'd now be squirting water out a considerable distance. So I'm satisfied with that. Structurally, it would have been nice to have held it there for a few minutes at least, but yeah, I don't think our jerry rig system is really going to do that. I'm quite impressed it's held up as much as it has. So yeah, I'm going to call that a win.
Tidy.
Tested. It's a win, Mark.
It is, that's quite good.
Why are you wearing all that?
Because the shrapnel.
Not scared, are you?
No.